Welcome to the Explainer. Today, we're diving under the hood of your servers to tackle a really common but, absolutely critical challenge in virtual networking: how to keep everything running smoothly without it all crashing into each other. So, let's just start with the core problem that, honestly, anyone running virtual machines is going to face. Inside one single physical server, you've got all these different types of data, and they're all fighting for the same resources. Just picture a highway with no lanes. Total chaos, right? Well, that's what can happen inside your server. So, to prevent a massive virtual traffic jam, you've got to create dedicated lanes for different types of traffic. In a VMware vSphere environment, this traffic comes in a few pretty important flavors. You've got your basic server management traffic. That's how you control the host itself. But then you've got something like vMotion, which is that amazing tech that lets you move a running virtual machine from one server to another with zero downtime. Now, if those two get tangled up, things can get really slow or, even break. So why go through all this trouble? It sounds complicated, right? Well, the benefits are huge. When you untangle that mess, performance gets a massive boost because your critical vMotion traffic isn't stuck behind some routine management task. Security gets tighter because things are isolated. And overall, you just end up with a much more reliable and manageable virtual environment. It's really a foundational best practice. Okay, so let's get into the how. When it comes to actually creating these separate data highways on a single server, VMware vSphere basically gives us two main blueprints. It all comes down to how you want to organize the flow of data, both in the virtual world and in the physical world. So the crucial point is this. Do you want to use one big virtual highway and just paint logical lanes on it using something called VLANs? That's method one on the left. Or do you prefer to build entirely separate highways, each with its own dedicated on-ramp to the physical world? That's method two. It's a choice between logical separation and physical separation. With this first method, everything flows through just one virtual switch. What we do is create different port groups. Think of them as connection settings, one for management, one for vMotion, and so on. Then, we give each one a unique VLAN ID. These IDs act like color-coded tags that tell the network switches exactly which lane each piece of data belongs in. It's pretty slick. Now, the second method, this is what you might call total isolation. You're not just painting lines anymore, you are building brand new highways. You create a completely new virtual switch for each specific type of traffic. And the critical part is that each of these virtual switches gets its own dedicated physical connection. It's pretty much the ultimate way to guarantee that these traffic types never, ever interfere with each other. All right, now that we get the virtual side of things, let's talk about how this all connects to the physical world, because this is where the virtual meets the real. And trust me, the hardware you choose makes a huge difference. In the VMware world, we call this physical connection a VMNIC. It's just the physical network card sitting in your server. Think of it as the on-ramp that takes all your virtual traffic and sends it out onto the real-world network. Simple as that. If you were to look inside a server room, say 10 years ago, you'd see a pretty common solution to this problem. Just throw more hardware at it. You'd see servers just packed with 8, 10, maybe even more 1 gigabit network cards, each one dedicated to a different job. But man, have things changed. Today, the best practice has completely flipped. Instead of that mess of slow connections and cables, the modern recommendation is to use just two very high-speed physical network cards. We're talking 10, 25, even 100 gigabits per second. And why the change? Well, it's way more efficient, it dramatically cuts down on cable and complexity, and it gives you this incredible fire hose of bandwidth to work with. So you've got these incredibly fast physical connections, but how do you manage all that power on the virtual side? This is where things get really, really interesting, because the type of virtual switch you choose fundamentally changes how you manage your entire environment. vSphere gives you two options, the standard switch and the much more powerful distributed switch. Okay, so here's the breakdown. The vSphere standard switch, or VSS, is configured individually on every single server. It's simple, and it's available with every vSphere license. The distributed switch, or VDS on the other hand, is a completely different beast. It gives you a single centralized place to manage networking across all of your hosts, and it unlocks a ton of advanced features. But there's a pretty big catch. And this right here illustrates one of the most important things you'll face when designing a virtual network. The decision isn't always purely technical. A lot of the time, it comes down to licensing and, well, budget. And there it is, While the distributed switch is, frankly, superior in almost every technical way, giving you that sweet centralized control and all those advanced capabilities, it is locked behind VMware's top-tier and most expensive license, vSphere Enterprise Plus. And this single fact can completely change your design. It means your budget directly impacts whether you can use the more advanced, scalable, and centrally managed networking features. The best technical solution might simply not be the one you can actually afford to implement. So, this all brings us to the final takeaway, which is really a question you should be asking about your own environment. When you're designing your virtual network, what are you actually optimizing for? Are you building for cost effectiveness and simplicity with standard switches where you manage things one server at a time? Or are you investing in the advanced features and centralized scale that the distributed switch provides? There's no single right answer, but knowing the trade-offs, that's everything.